All right, let's talk about something that feels, well, kind of like magic. Large language models, right? LLMs. Today, we're going to pull back the curtain, get rid of all the complicated stuff, and really see what's going on under the hood.
I mean, really think about that for a second. What if everything driving these incredible AIs could be understood with math you probably learned in, like, 7th grade? I'm talking basic addition and multiplication. Sounds crazy, right? But that's exactly what we're going to do. No jargon, no crazy formulas, just the core ideas.
Yep, you heard that right. We are going to build one. Metaphorically, of course. We're starting from scratch with the simplest possible idea, and we're not stopping until we've put together the whole thing. It's going to be a fun ride. So you ready? Let's get into it.
Okay, first up, the magic is just math. We've got to start here. Because before we get to the large part of LLMs, we need to get our heads around the basic building block. And spoiler alert, it's not some kind of thinking, conscious entity. It's really just a digital brain that only understands one thing: numbers.
Okay, if you remember one thing from this whole explainer, make it this. A neural network is basically a glorified calculator. That's it. It only eats numbers, and it only spits out numbers. The whole trick, the art of it, is how we, the humans, decide what those numbers actually mean.
So let's make this super concrete. Imagine we want to teach a computer to tell the difference between a leaf and a flower. Now, a computer has no idea what a leaf is, but it loves numbers. So we have to translate the real world into its language. We can measure things like the color, the red, green, and blue values, and maybe its volume. We just turn those features into a simple list of numbers.
And here's what the network does with those numbers. It's shockingly simple. It takes each of our input numbers, the R, G, B, and volume, and multiplies it by another number, called a weight. You can see those weights on the lines connecting the circles. Then it just adds them all up. That's pretty much the entire operation. Multiply, add, repeat. That's the secret sauce.
So let's just get the terminology straight right quick. See the circles? Those are the neurons. They just hold the numbers. And the lines connecting them? Those have the weights on them. The weights are super important. They're what the model actually learns. But yeah, that's the lingo: neurons and weights.
And this is so important to get. The network has zero clue what a leaf is. It's not thinking, that looks leafy. All it did was spit out two numbers, 0.8 and 0.2. And because we, the humans, decided beforehand that the top number represents leaf, and because 0.8 is bigger than 0.2, we call the result leaf. We are the ones giving it meaning. The whole thing is just a fancy calculator doing what we told it to do.
Okay, moving on. This next part is the real aha moment. We just saw how this math can tell a leaf from a flower. But how in the world do you go from that to writing an email or a poem? This is the big leap, where we see how this exact same idea applies to words.
Check this out. It's the exact same setup. On the left, instead of features like color and volume, our input is now just a string of letters, like Humpty Dumpty. And on the right, instead of an output like leaf or flower, our output is the next letter, in this case, Y. We've turned a language problem into a classification problem.
And look, it's the same diagram. The math inside is identical. All we have to do is turn letters into numbers, which is easy. We can just say A is 1, B is 2, and so on. We feed in the numbers for H, U, M, P, T, Y. The network does its thing, multiply, add, and at the end, it spits out a bunch of scores for every possible next letter. The one with the highest score wins, and in this case, that's the letter Y. Now this is where it gets really cool. This is the generative part. So the model predicts Y. What do? We take that Y, stick it on the end of our input, and feed the whole thing, Humpty Dumpty Y, back into the machine. Now it predicts the space. Okay. We feed that back in. Now it predicts S, then A, then T. It's building the sentence one letter at a time by talking to itself. That's it. That's generative AI in a nutshell.
All right, section 3, the superpowers. So predicting the next letter of Humpty Dumpty is neat, but it's a universe away from what ChatGPT can do. So what's missing? What are the big upgrades that turn our simple model into a truly large language model?
It really boils down to 3 game-changing ideas. First, a way better method for turning words into numbers, called embeddings. Second, a smarter way to chop up text. And third, and this one is the real secret sauce, something called self-attention, which is how these models understand context.
So remember how we just said A is 1, B is 2, that's kind of dumb. It doesn't capture any meaning. Embeddings are totally different. Instead of us picking the numbers, we let the model learn the best set of numbers for each word. And what happens is that these numbers, these vectors, actually start to capture the meaning of the words. So the number list for king will be really similar to the one for queen in a mathematical way. But the number list for king and, say, toaster will be miles apart. It's learning relationships. Okay, but here's the real test. Context. Look at this sentence. Damien had a secret child, a girl. His will belong to who? What goes in that blank? It's got to be her, right? But why? Because of the word girl, which appeared way earlier in the sentence. How does a machine, just looking at the last few words, figure that out?
The answer is an incredible trick called self-attention. You can think of it like a spotlight. For every new word it's about to generate, the model can shine a spotlight back on all the previous words and decide which ones are the most important for what it's about to say. It learns where to pay attention.
Now, don't worry about all the arrows and math here, let's just get the big picture. To figure out what comes next, the model creates a little query based on the last word. It's like asking a question. Then it compares that question to all the previous words, which act like keys. The result of that comparison is a set of important scores. It's literally a list of numbers that says, pay 70% attention to this word, 20% to that one, and only 10% to that one over there. It's how it knows girl was the important word in our last example.
All right, last section, the final blueprint. We've got all the pieces on the table. We have the basic math, we have the generative loop, and we have our superpowers, embeddings, and self-attention. Now it's time to snap them all together and see what a modern LLM actually looks like.
This, right here, this is the engine, the fundamental Lego brick of models like GPT. It's called a transformer block. And look what's inside. It's got our self-attention mechanism, and it's got a simple network just like the one we started with. This block is the powerhouse that does all the heavy lifting. It takes in text, understands the context, and gets it ready for the next step.
So if that little block is the engine, how do you build a whole car? Or in this case, a massive model like GPT? You just stack them. You take the output from the first transformer block and plug it right into the input of the next one. Then you do it again, and again, and again. Sometimes dozens of times. That's what makes the network deep and gives it the power to understand really, really complex language.
So let's just do a super quick flyby of what we just did. We started with dead simple math, right? Just multiplying and adding. We figured out that the secret was all in how we interpret the numbers it spits out. Then we gave our little model some superpowers, embeddings to understand meaning and self-attention to understand context. And finally, we saw that the pros just stack these powerful blocks on top of each other to build the final architecture. Pretty cool, huh?
And that's it. That's the journey from middle school math all the way to the heart of GPT. So it's not this magical, mysterious black box after all, is it? It's just a series of clever, understandable ideas all built on top of each other. Hopefully, the next time you use one of these tools, you'll see the incredible math doing its dance behind the scenes. So now that the magic trick is revealed, what are you going to ask?